Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 24th of June, 2025 T, 15 hours, 3 minutes, and 57 seconds, 0.0000Z. This paper, published just 2 days ago, introduces a new training framework that dramatically improves how models perform after aggressive 4-bit quantization. The paper is titled Outlier-Safe Pre-Training for Robust 4-Bit Quantization of Large Language Models. And as we'll see, the results really challenge some common assumptions. The authors propose that extreme activation outliers, which hurt performance, aren't an inherent property of LLMs, but a direct result of our training choices. Also, the authors shared their implementation on GitHub. And if you're curious to try this out, the repository has everything you need. You'll find the full evaluation code, model checkpoints, and all the scripts to replicate their quantization experiments using methods like RTN and GPTQ. You'll find several 1.4 billion parameter models on Hugging Face, including final and ablation versions. They're base models, best used for evaluating quantization performance. Alright, so to really see what's happening inside these models, the authors provide these powerful visualizations. We're looking at 3D histograms of the model's activations, which are the numerical outputs from its internal processing units, specifically at the input to the multi-head self-attention and feed-forward network modules. On the left, you see a model trained with the standard Atom optimizer. And wow, look at those huge red spikes. Those are the extreme activation outliers. In the middle, just using the new Muon optimizer helps, but outliers are still there. But on the right, with the full Outlier-Safe Pre-Training framework, the activations are smooth and uniform. The spikes are completely gone. This shows their method doesn't just reduce outliers, it prevents them from forming in the first place. Building on those visuals, this table really breaks down how they achieved that result. It's what's called an ablation study, where they test their full Outlier-Safe Pre-Training system by taking it apart piece by piece. Look at the X-curt column. That's excess kurtosis, a statistical measure of how spiky or outlier-prone the activations are. The standard Atom model is over 1800. But the full OSP model at the bottom, which combines the Muon optimizer with Single-Scale RMSNorm and a learnable embedding projection, drops that number to almost 0. Critically, it also maintains top performance under aggressive 4-bit quantization. Okay, so these plots show the training dynamics over time. Basically, what happens as the model learns from 100 billion tokens of data. On the left, we have the training loss, which is just a measure of the model's error. You can see all the methods learn effectively. Their error rates go down at a similar pace. But the plot on the right, showing that excess kurtosis, or spikiness, tells the real story. For every method except one, the kurtosis explodes. Only the full outlier-safe pre-training system, the green line, keeps it flat, right near 0. Proving that all its parts are essential to prevent outliers from ever forming. So keeping that kurtosis flat during training is one thing, but does it actually lead to a better performing model? Well, this table gives us the answer. It compares a dozen open source models against the 2 models trained from scratch, one using the standard Atom optimizer, and the other using the full outlier-safe pre-training system. After aggressive 4-bit quantization, look at the average scores on the far right. The Atom-trained model gets a 26.5, but the outlier-safe pre-training model jumps to 35.7. That's a massive improvement, showing just how much robust performance you gain by preventing outliers from the start. So what's the big picture here? Well, the key takeaway is that those extreme activation outliers, the ones that wreck performance when you try to quantize a model, they aren't inevitable. They're a side effect of our training methods. This new outlier-safe pre-training framework proves that you can train a large model from scratch to be inherently robust, keeping that statistical spikiness, or kurtosis, near 0. The result is a model far more resilient to aggressive quantization, with only a tiny 2% training overhead. That's all the time we have for this week's AI Research Roundup. Thanks for tuning in.